Hi, folks. I'm Chase. This is Chris. We work at Rackspace, and we've been working on cloudy things for a while. um, so, purpose of today's presentation: building a better cloud. We're going to take a bit of a closer look at the Rackspace OpenStack Flex product. We're going to take a brief overview of drivers that led us here, the impact that it's had both business-wise and technically. And I'm going to turn it over to Chris for some technical details, what this product looks like. So, here's my one slide I'm going to talk to. I'd like to start with a brief history of kind of how we got to our OpenStack Flex product. Back in 2008, we acquired SliceHost to get into the cloud game, and this was a custom cloud control plane based on Zen hypervisor, and then we evolved into the development and early adoption of OpenStack components. We're tying in some consumption products and adding some non-OpenStack products and some custom configs and custom features along the way, which was born into our OpenStack public cloud product. It's been a very successful product, and I like it very much. But some business drivers came along that have allowed us to pursue opportunities that we've wanted to for a while. So we had a company directive to align and adopt modern OpenStack. We wanted to get involvement in the community, and we wanted to contribute back to the project, right? We had a lot of early involvement, and we loved the energy and the excitement in the community that we were with. We strayed, but we want that back. We want to capture that. There are varying business aspects behind that, but we wanted to be back there with the community. Along with some standard business drivers that I'm sure everybody in this room has, right? Increase efficiency, security, reliability, operability, automation, reduce costs, reduce overhead. Everybody has these, right? So combining all these things and with a specific focus on aligning different business organizations that touch on OpenStack components to have a unified customer experience, a seamless customer experience between the OpenStack products, we had a very specific and exciting window of opportunity, right? So we seized it, and we started building what is known as the OpenStack Flex product. So I'm going to briefly touch on just some architectural, engineering, and operational alignment issues and problems that I shouldn't say problems, I should say challenges, which would create opportunities for us, right? It's fun to think of that way. Every problem is just a puzzle waiting to be solved, right? So unification between products that use OpenStack, right? This was a great opportunity for us to look across our company and our organization to see where we can make efficiency improvements, where we unify the tech stack, so therefore we can unify people with similar skill sets and put them into more specialized and more efficient and effective teams. And we can minimize their focus so we can get higher output, higher quality products. Of course, one of the major factors there that we like also is the reduction of operational overhead. Right? We can stop recreating the wheel independently in different organizations. We can stop building pet projects, and we can unify and focus on more specific areas. One of the driving factors for us in engineering was this was a great opportunity for us to pursue a more modern hardware footprint and a higher density, higher capacity, higher density hardware, as well as a more modern software set. So, you know, this is exciting stuff to engineers, right? We want to be as modern. We want to touch the new bits as much as possible. That leading, just to give you an example, like we have dozens and dozens of unique hardware profiles that all take operational overhead, especially for upgrades or deployments. And now we're down to a couple of Dell hardware profiles in OpenStack Flex. So the manageability and the operability are vastly improved there. Moving into a couple of the infrastructure aspects Like I mentioned before, we had a lot of custom stuff, non-OpenStack components. I would just refer to those as Rackspaceisms, as we do, where we just added some flavor. But as you'll probably know, you look at the futurability of that, and you know you have technical debt and problems in your near future. One of them being our patented iNova. It's our cloud that runs our production cloud. We needed to upgrade into modern upstream OpenStack for that, and actually retire that. We had a completely virtualized VM control plane, thousands and thousands and thousands of VMs. We have switched now to a containerized model, as you know, increases our capability to write infrastructure as code, increases the reliability. Our capability to manage and to self-heal is vastly increased. And then we're getting into things like our upgrade and our patching process. Previously, we were pulling OpenStack daily, and we were packaging into a bundling framework. We had to maintain a massive framework to address the Rackspace isms, and we had to cut packages, and then we had to go through a deployment process, which is hugely Ansibleized with a monolithic, complex Ansible deployment process. Got rid of that. We use Helm. We Helm upgrade now from base OpenStack. That took. I mean, I can't even quantify the amount of hours that we spent in engineering that piece solved right there. Some other issues that we've solved just with Flex is our QE process and our testing and our benchmarking. We used to have entire teams dedicated to maintaining QE and testing environments, Jenkins infrastructure, Cloud Cafe, writing tests, maintaining tests, upgrading tests. Now we use Rally and Tempest with a couple of integration tests, a custom integration test. And also another example off the top of my head, not in my notes, is Nova scheduler filters that we were having to maintain and to build in each one of these releases. Now we just use placement. So a lot of focus towards the modern feature set, which has made our product a lot easier to manage, and a lot more feature rich already. And so tying that all together, from a leadership or a product management perspective, right? We get to squeeze out a lot more, and frankly, in my opinion, a lot better with a lot less resources, a lot less hardware resources, a lot less labor resources, and so this is good for us. And not to downplay, we get to rejoin the OpenStack community again, a lot more heavily and a lot more focused and business sponsored we did before. Oh, I'm running out of time. I only got like 2 more bullets. Yeah, so tying this up, right? We get to build a better product, but in the process, we get to align with engineers across our org, and they actually get to build more valuable skill sets. So we get a better infrastructure and better engineers, and everybody's happy, so it's a good thing. All right, Chris.
All right. So thanks, y'all, and yeah, happy to be here. Want to reiterate that, and I'm going to talk about kind of what we're building internally for both the public cloud, which I work on, and the private cloud folks, which work closely with. And it's nice to be aligned on the kind of the same build process with a lot less change. I should have done that already. So we're building methods to enable everyone to deploy OpenStack on and along with Kubernetes. We want to use open source tooling to do it, and anything that we add to that process, we also want to release back to the community. So you may have seen this in a keynote yesterday. This should be pretty familiar to everybody, but what we're doing and what a lot of people are doing is laying down a Kubernetes cluster and then installing OpenStack alongside of it. And this kind of represents what that looks like. So there are 3 stages to it. There's the Kubernetes deployments portion. There's the infrastructure components for OpenStack, things, MariaDB, Rabbit, so on and so forth, and then the OpenStack services themselves. But you have to start somewhere with bare metal, turtles all the way down. Bare metal, bare metal's is somewhere. So with that, you have some decisions that you have to make on your own, like what your hardware is, and procurement, and getting all that set up, networking configured, and then you can get to the 3 stages, which I should have already clicked that. Sorry, I'm clicking here and on my notes. So to get started, we have a project that's at github.com, Infra Labs, where we have calling it GenStack or OpenStack Flex, where clone a repository, set up a virtual environment based, in that repository, install Ansible dependencies, because we're using KubeSpray to do the initial install, and then setting up the environment. So the Kubernetes part, of course, with KubeSpray, you're gonna, or any Ansible really, you need an inventory set up. You need your vars, your KubeSpray vars for that. So things like, depending on how you set up your networking gear, your network bonds, stuff as simple as your NTP IPs, that sort of thing. And then you go and install KubeSpray. It's pretty straightforward. We like KubeSpray because while there's a lot of testing that's already been done in the KubeSpray community to make it work, and you can pretty easily add and remove nodes if needed. You can upgrade your Kubernetes version when the time comes, so on and so forth. Here I have Infra Deploy Playbook. This is kind of for a lab environment. We've moved away from it, and I'll talk a little bit more about that. But after you've installed Kubernetes, a couple other components you need to lay down. That's things like MetalLB for load balancing. There's Let's Encrypt for certificate manager inside the cluster, Gateway API for ingress, all installed with Helm to add the functionality in Kubernetes that you need to run OpenStack. There are steps to install a Ceph cluster. We have an external one on some, I think, Dell gear. I don't have to worry about the storage, so I'm happy. We'll move on from that. So once you get past that, you're into the OpenStack infrastructure components. So these are things like MariaDB, RabbitMQ, libvirt. All things should be very familiar, but we like to use the operators available from the providers of these. And we like the operators because you are able to, through command line or through Kubernetes manifest files, create the databases, create database users, do database backups. In case of RabbitMQ, you create your queues, you create your users. And you don't have to manage a cluster independently, which was what we had to do in the past. We had Rabbit clusters and MariaDB clusters and had to manage that on VM. So if we can step away from that, that makes everybody's lives easier. We also, of course, Prometheus. I don't think you can really say Kubernetes without Prometheus, or the other way around. And then our log aggregation, which we use Loki, and then expose that stuff through Grafana. We like Loki because it's API endpoint to logs that allows you to hook that up to dashboards, allows engineers with PromQL queries, which are a lot like Prometheus queries, to get the information out of logs. So if you want to look at, like, if you have a node label that you want to get all the logs for, or some deployment label on pods or something like that, you can get down to those really fast. So that's pretty helpful. And then the last part, of course, is OpenStack, which I guess y'all are pretty familiar with that here. All these services we deploy using OpenStack Helm charts to get it done, and then for customizations we use Customize to customize the deployment. And that allows us to kind of decouple the configuration from the Helm chart, so we can use the upstream Helm charts without making any changes. We don't have to change so much locally and do Git merging and whatnot to keep it all under version control. We can do that within. We can do that a little bit separately, and it's just a lot easier to deal with, in my opinion. And then last is the stuff like, not everyone has all this access to hardware and whatnot to do that, but I bet most of y'all have access to a Kubernetes cluster or two, or I mean, a OpenStack cluster or two. So and I've had a lot of hand in this, built a bunch of OpenTofu manifests to deploy something a lot like this inside of an OpenStack cluster. And this is a pretty reasonable replication or representation of what we have in production, down to a little bit. Now, in the past, we used some Ansible just to talk to the OpenStack endpoint, spin up nodes, do what you need. But then you're down to you're done deving or iterating or testing or whatever you need to do. Now what? Now you have to, like, the playbook didn't tear it down. So you either had to do that by hand, going through a dashboard, or OpenStack CLI. Oh, did I forget this network or this subnet or who knows? So use OpenTofu to represent that, and allows this is a 30 node cluster which has the Kubernetes components and all the OpenStack components ready for the kube spray, and it'll spin up in about 2 minutes. And then when you're done with it, you can just tofu destroy, and it's gone, and iterate again. That's saved us a whole ton of time, and this will be released by the end of the week. So I've said it publicly now, so now it has to happen. GitHub.com/Rackerlabs. And yeah, we're using Skyline. This is actually, I do my dev work not in production, but on top of production. So it also kind of gives us a little extra stress test by the engineers all day, every day. So yeah, I think that's yeah, I think that's a good thing. And yeah, well, as we said, we're doing this stuff in the open again, which I'm really happy about. Great to be back in the community, especially as a person in the open source community back in my hometown. And this stuff is available at docs.rackspacecloud.com, and the repo, the deployment repo is at github.com/Rackerlabs, and you can expect to see something named something tofu flex there as well, but by the end of the week. So with that, any questions? I get to go look at the video in a couple weeks and see how big my jar is. My donations.
Can we download?
Yes.
Can you download your distribution from next week? From this site?
I'm gonna have you start your question again so everybody can.
When can I download your Flex distribution?
So you can take a look at the OpenStack Flex deployment stuff right now, and that's, if you go to docs.rackspacecloud.com, you can see that and grab that. As far as the OpenTofu /Terraform things, by the end of the week it'll be a repo public on GitHub, and if you have access to an OpenStack cluster, you would be able to run that and spin up what we're doing there for testing and investigation and that.
Your Flex is 100% pure open source technology, right?
I'm sorry?
100% pure open source.
Yes, at this point there's nothing closed that we're doing. I mean, we're using OpenStack Helm to make stuff easy to do, easy to deploy, and not like, in the early days, one of the things we did is we pull stuff down from public OpenStack, and then we'd have to do some proprietary stuff to make it work in our cloud. It wasn't for anyone. It wasn't useful for anybody else, but it was. Have you ever had to use Mergefly? man, that's not fun. You know, when you got up to 200 patches, yeah. No, thanks. So yeah, it is 100% open source.
Thank you so much.
Any other questions? Great, thank you so much to Rackspace Technology.
All right, thank you.